Hello and welcome to the class on Poisson distribution. We studied that the probability distribution can be categorized according to the nature of the variable. The discrete probability distribution can be binomial and Poisson, whereas continuous probability distribution can be normal distribution. Poisson distribution is a distribution of number of times a rare discrete event occurs in a continuum of space or time. The Poisson distribution gives the probability of x number of events which are occurring in a specific time t. Simon Poisson proposed this distribution in the year 1837. The distinction between Poisson distribution and binomial distribution is that in binomial distribution, n, the number of trials, is known. We can also count the number of times an event occurs or the event fails to occur. Whereas in case of Poisson distribution, n is not known or it is infinitely large. We can count only the number of times the rare event occurs. We cannot count the number of times the event failed to occur. The Poisson event is a rare event because the probability of its occurrence is very small, and the Poisson distribution can be generally studied in the spatial sample or the temporal sample. These are the examples of Poisson events in a continuum of time and the Poisson events in a continuum of space. The Poisson probability distribution is based on the mathematical constant E, which is equal to 2.7183, and it is the base of natural logarithm. The parameter required to derive a Poisson distribution is m, which is the mean number of occurrence of the rare event. The successive terms of the expression e raised to minus m into e raised to m gives the probability of the occurrence of the Poisson event at specific times in a continuum of time or space. If m is the mean and x is the number of times the Poisson event occurs, then the probability of occurrence of a Poisson event x number of times can be given with the formula e raised to minus m into m raised to x divided by x factorial. Properties of Poisson distribution can be categorized as: the Poisson distribution is defined by a single parameter, the mean m. The variance of the Poisson distribution is equal to the mean of the distribution, and therefore the standard deviation will be equal to the under root of m. The Poisson distribution tends to be normal as the mean increases. The Poisson mean, the Poisson variance can be expressed with lambda, and therefore the standard deviation can be expressed as under root of the lambda, where lambda denotes the expected number of occurrence of an event in a given time period or space. Poisson distribution is used to find the distribution of plants and animals. It can also be used to understand the occurrence of incidences of specific diseases. Thank you.